Hello, my name is Marek, and I'm going to give you a high-level brief overview of the tool Symbiotic, which is, as we saw, one of the tools that the Red Hat guys and Honeywell guys are trying to deploy in their verification cloud as a part of the Aufhover project. So, what is Symbiotic? Symbiotic is a tool for finding bugs in mainly C programs. We target sequential programs, but we have also kind of support for parallel programs, so it's not working that well yet, but we hope that it's going to get better in the future. In a nutshell, Symbiotic uses a combination of lightweight static analysis, program transformations, and symbolic execution. And design-wise, it's highly modular. It's basically a set of C++ modules that are glued together with Python scripts. So how does it work? Well, there are three main stages that the program goes through during the verification. And let's take it on an example. Well, in fact, Symbiotic internally works with LLVM, so the steps do not look that fancy as I will show you on the slides, but let's stick with the C code. So the first phase of running Symbiotic is instrumentation. In the instrumentation phase, we detect possible bugs in the code and somehow mark them. By marking them, I mean that we just insert some call to a dummy function that tells the two other stages that this is a place where there can be an error. Alternatively, for some kind of errors, we can directly insert checks for the error. For example, we can, or instrumentation could insert assertions like these for the value of size and I variable to detect the buffer overruns. Actually, the main purpose of instrumentation is, well, not to insert the checks as such, but to highlight the places in the program where the program can go wrong. And that is important for the next phase, which is program slicing, that takes the instrumented program and removes from it all the parts or the statements that cannot influence the highlighted possible error locations. So in this case, if we are interested in these assertions, then the computation of minima and the accesses to the array are redundant during the verification of the assertions. So we can remove them, and we are left with a much smaller program. Well, usually much smaller program, and this program can then be analyzed by, let's say, arbitrary verification technique. We use symbolic execution by default, and how does it work, I will tell you in a minute. So some details to the components. Well, the instrumentation, the first phase that marks the possible bugs and inserts the marks to the code or checks to the code. It is in Symbiotic, we've got a module that is user configurable. User just gives some configuration in JSON to it, some let's say definition of functions that you want to link to the module if you need them. But what's the main feature is that we can or the instrumentation module can use some static analysis as plugins that just, let's say, scan the code and tell the instrumentation, okay, here you need to put the mark because here may be an error, and on the other places they say just, okay, here it's error-free, you don't need to insert any code here. And we of course do not need to use instrumentation for any kind of errors. If we are interested in the assertions, as we saw in the example, we do not need any instrumentation. But if we are interested in codes like memory safety errors or signed integer overflow, we need to use this instrumentation to mark the possible errors in the code so that we can slice the program. We also have instrumentation for simple non-termination checking, that is detection of infinite cycles. The program slicing part, that's actually the main part, except for the symbolic execution in Symbiotic, is the part that removes the redundant code. And we can slice the program. To slice the program, you need to compute the dependencies between statements. Okay, so how to do that? Well, there are basically two kinds of dependencies. There are data dependencies, which let's say arise from the cases where one instruction writes to memory, the other instruction reads from memory, and it reads the value written by the first instruction. And to compute these dependencies, we need to analyze the accesses to memory. So for that, we need some kind of pointer analysis. And that's, I mean, those are the details that I'm hiding from you here, but just to remark that all these kind of things need to run in the background to resolve the targets of pointers, and so. And the other kind of dependency is control dependency, which arises, well, just one statement controls the execution of the other. So let's say if we have a if statement and something is executed only if this if statement is true, then there is this control dependency. And once we compute all these dependencies, we can just check on which statements is the error location or the possible error location dependent, and we remove the rest and keep only those dependent statements. Okay, and the last main phase in Symbiotic is symbolic execution, which is a, let's say, technique that enumerates all possible paths in the program. Of course, if there's only finitely many of them. And for that, we use symbolic executor CLI, which is open source. You can find it on GitHub. We got our own fork with some modifications. And how does symbolic execution work? Well, it's as this name, it's execution, but instead of using concrete numbers, you just use symbols. And why is it good? Let's say you got this small code snippet, and there are variables x and y, and let's say the x and y is input by user. So in this case, I mean, user can input arbitrary values. So to search all the paths in the program, instead of the concrete value put by user, we use a symbol. In this case, we call it x bar and y bar, and then execute the program. And the program starts executing, and it runs into the first statement, which is if this statement, and there's the comparison of variable x, where it is greater than 0. Okay, and x contains now the symbol x bar, so we issue some constraints over that and ask whether this condition can be satisfied. And the constraints will tell us that, yes, it can be satisfied, so the symbolic executor continues searching the true branch. But, of course, we can ask also whether it is possible that this condition is not satisfied. And in this case, it is possible, because x can be arbitrary, so it can be less or equal to 0. So the symbolic executor forks and follows also this path. And this way, the symbolic executor is able to let's say, search the path space of the program, and if it runs into a path where there is an error, let's say, for example, this one, where the input x plus 1 is not equal to the input y, it reports the error. Okay, well, I presented Symbiotic as a verification tool, but actually it's rather a framework. But the presentation as verification tool fits more into the spirit of the Aufhörer project. But Symbiotic contains a bit more functionality than just the verification part. Well, first of all, we have modules to decompile the LLVM back to C, so we can use Symbiotic as a C2C transformer that just takes the program and spits out another program that is sliced and prepared for verification, or we can use it just as a C to LLVM compiler. course, symbolic execution is nice, but there are many other techniques for verification of programs, and we can, instead of CLI, we can plug into Symbiotic many other tools like CPA Checker, Divine, Seahorn, ICOS. The list is not complete by far. And one, well, actually quite experimental feature now is that we can also generate some executable, let's say, witnesses of the crashes, only with some backends, so that you can like take the binary, load it into debugger, and just trace the error in the debugger. Okay. So to sum up, Symbiotic, well, you can use Symbiotic to find errors in your program, and the main steps are, well, you just detect possible errors in the code, then you remove the rest that is unimportant for you, and then you try to verify the code by default by symbolic execution, but you can use any other tool that consumes LLVM or C. Or you can use Symbiotic as a compiler that somehow prepares the code for verification. And it is highly modular, so you can just take any part of it and plug it into your project if you want. And that's, I think, all for me. Thank you.
Thank you. Questions? Honza, Kofroni?
Thanks for the talk. Actually, if you identify, I hope you have not said it, if you identify the statements to be removed, to be sliced off, do you consider global variables and pointers and these things?
Yes, I was talking about the pointers. I was not talking about global variables. Actually, the slicing that we have is interprocedural, so it computes the dependencies, like also between the procedure boundaries, and well, it computes the dependencies for the whole program. So yes, we can handle global variables. We can handle access via pointers, or we need to, because otherwise, I mean, we would be getting really like funny results.
Thank you. There. Yep. Okay.
Thanks. Given that you're doing symbolic analysis with Symbiotic to test code coverage, are you then enjoined from being able to test conditions that might result from architecture-dependent behavior, like underflow or overflow, or is that covered by another backend?
It's a business of each backend, these things, but yeah, some of the backends, for example, I think Divine, which is going to be the next tool presented, can do stuff like that.
So for complete coverage, you might have to run it twice with different backends.
Oh, I don't know. I mean, it depends on the let's say modeling of the environment. I mean, the verification tool can just say, I mean, these are the possible behaviors, and if any of these like leads to a crash, then report the bug. So, but yeah, I mean, if the verification tool has a switch that tells the tool, okay, now assume this environment, like this architecture or anything, then yeah, you need to run it for each architecture separately.
Okay, thanks.
Another question or remark? So in fact, I have one if I can. So this is more a remark. So one thing that I like is that recently within the project that we mentioned, Symbiotic was combined with Predator, which is a tool developed at Brno University of Technology. In fact, the original author is Kamil, who started in something like Kamil Dudka in 2012. And amazingly, the tool, even after the years, is still one of the best in the category of SVCOM devoted to verification of memory-related issues, which is amazing. So a lot of credit to Kamil. And I'm happy that the cooperation is here. Okay, some further question or comment? Okay, no, then let's thank the speaker once more.
Thank you.